So in this video, the first thing we're going to talk about is how you can use these trigonometry functions to help you solve for missing sides or missing angles of a right triangle. The first thing we need to go over, though, is where and how you use these trig functions on your calculator. Now, if you're on a scientific calculator, all you should have to do is hit like your sign button and then type in 40. You do not need to put in the degree symbol, and then hit enter, and it should give you the decimal approximation for that ratio. If you're using a graphing calculator, the first thing you have to check for, and on the scientific you don't really have to worry about this, it's only on the graphing calculators. For some reason, the graphing calculators default to what we call radian mode, and we'll talk about radians later on in this chapter, but we need this in degree mode. So the first thing you have to do if you're working on the graphing calculator is hit the mode button at the top, and notice on the third line how mine is highlighting the word radian. We need to highlight the word degree. Then your sine, cosine, and tangent buttons are located here. After that, we should just be able to hit sine of 30, and it should give us the answer. Okay? You may want to try that on your own calculator. Sine of 30 is a nice, easy one to do. It should come out to be 1/2 or 0.5. So try that on your own calculator. And if it's not working, put a question mark or write that question down over in the side of your notes over here, and I will be happy to help you in class. But if you're on the graphing calculator, always make sure that you check that you're in degree mode first. Okay? All right, so let's look at this example. It says find the value of x for the right triangle. Well, notice what you're given in the picture. We're given this angle 30. What you want to do is you want to look at what side you were given in relation to this angle. Okay? Well, the first thing I notice is that the hypotenuse was given to me. It's an 8. Okay? The x, you kind of need to decide, is that the opposite leg or the adjacent leg to the 30-degree angle? Well, the x is right next to or is connected to the 30-degree angle, so that is adjacent. So what we need to use is we need to use the trig function that uses the adjacent leg and the hypotenuse, and that would be cosine. So this is a cosine problem, so I'm going to write down the formula. The cosine of my angle is the adjacent leg over the hypotenuse. Now what I'm going to do is I'm going to fill in what I have, and I'm going to solve for the part I don't have. Well, it's the cosine of my angle. Well, I have my angle. It's 30 degrees. Is equal to the adjacent side. Well, that's marked x over the hypotenuse. Well, that is 8. This is a very easy problem to solve. This is now just an algebra problem. Since it's x divided by 8, if I want to get the x by itself, I am going to multiply both sides by 8. And so I will need to do 8 times the cosine of 30 degrees. And you can type that in your calculator. You are just going to type in 8 times cosine of 30. And that gives you approximately 6.93. The little squiggly marks instead of an equal sign just means approximately. But there you go. If you have any questions over this example or not sure what happened, just make sure you write any questions you have over here and we will address those first things in class. Let's look at one more example. Let's look at this one. Now this one says to solve the triangle ABC. Whenever they ask you to solve a triangle, that means that you need to find all of the missing sides and angles. Now I have listed out what is missing. We were given angle A is 28 degrees, and we were given that side B is equal to 15. Since they want us to solve the entire triangle, I need to find side A, side C, and angle B. Now, it doesn't matter which one you do first. Start with what's going to be the least amount of work. And if you remember from geometry, since this is a triangle, the angles of a triangle always add up to 180 degrees. And so what I'm going to do is I'm going to find angle B first. I already have two angles. I have 28 degrees and 90 degrees, which gives me a total of 118. Well, whatever's left over has to add up to 180. So I will do 180 minus 118. And that means that angle B has to be 62 degrees. And so there's one missing piece. Okay. Now we need to solve for our sides, and this is where we'll probably use a trig function. When I go to solve for one of the missing sides, I really like to use the information that's given to me. They gave me angle A, and they gave me side B. And so I want to make sure I use those. And I think I'm going to solve for side A first. Well, side B is the adjacent leg to the angle I have. Side A is the opposite leg from the angle I have. And the trig function that uses opposite and adjacent is tangent. So I'm going to write down the tangent formula. Tangent of my angle is equal to the opposite leg over the adjacent leg. And just like the last problem, I'm going to fill in what I know. I know my angle A is 28 degrees. The opposite side is just marked A, and the adjacent leg is marked 15. And just like the last problem, I can now multiply both sides by 15. Oops, that's an A. And 15 times the tangent of 28 degrees gives me approximately 7.98. And so now I have side A. Now, you have an option to find side C. You can use another trig function. Or, because we now have two sides of the right triangle, we can do what we did from the last video and just use the Pythagorean theorem. And we can do 7.98 squared plus 15 squared equals c squared. And you can do that and solve for that third side as well. It doesn't matter. Either one is fine. And when you have something like this, you can type that all in at once. 7.98 squared plus 15 squared equals. You now know this whole side is 288.68. Now that's equal to c squared. And so to get c, you will need to square root both sides. 288.68. Oops, I forgot to get square root. Square root 288.68 gives you approximately 16.99 or approximately 17. And now that you have found all of the missing pieces, you have solved the triangle. Again, any questions you have, please write over here. All right, let's look at a real life problem. This one says you are hiking near a canyon. While standing at A, you measure an angle of 90 degrees. That's right here. I'm going to go ahead and draw the picture over here so you can see a little bit better. It's a little hard to see on the dark picture. You then walk to B and measure an angle of 76 degrees between A and C. The distance between A and B is about 2 miles. How wide is the canyon between A and C? So that is what we're missing. Again, a lot of times if you can just get a picture drawn, the problem is not difficult. It's just that you need to see the picture to really have a good idea of what side you're dealing with. So looking at this, I'm given this angle right here, so this is going to be my point of reference. The sides that I have is I have the side opposite this angle. I also have the side adjacent to this angle. Notice the hypotenuse is not used at all. And the only trig function that doesn't use the hypotenuse is tangent. And so now I'm just going to fill in what I have. It will be the tangent of my angle, which is 76 degrees, is equal to the opposite side over the adjacent side. And again, I've now turned this into an algebra problem. Since it's x divided by 2, I'm going to multiply by 2 to get that by itself. And 2 times the tangent of 76 degrees is about 8.02. And since they were using miles, we will use miles as our unit as well. Again, any questions over any of the examples, write down in the box and we will address those first things in class. One last thing in this example I'd like to talk to you about is what we call the angle of elevation and the angle of depression. It says, if you look at a point above you, such as to the top of a building, the angle that your line of sight makes with a line parallel to the ground is called the angle of elevation. Picture this as your eyeball. There's a horizontal line coming out, and then there's your line of sight coming out. The angle in between them is the angle of elevation. Okay? If you're at the top of the building looking down, again, you have the same two lines. Picture this as your eyeballs. Here's a horizontal line coming out. Here's your line of sight looking down. This is your angle of depression. This is really where you just need to understand what angles you have so that you can draw your picture correctly. Let's look at this last example. It says a parasailer is attached to a boat with a rope 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. Now, there is to be no laughing at Mrs. Cole's pictures. I am not into teaching for art. I have no artistic ability. But really kind of picture what a parasailer looks like in the air, okay? So you have your boat. Again, we'll just pretend that looks like a boat, okay? And the boat is on the water, all right? And the parasailer is attached and is up in the air, okay? So here's your little person, okay? It tells you from the boat to the person, the angle of elevation is 28 degrees, and the rope that is attaching the parasailer to the boat is 72 feet. And it's asking for the height. Whenever they ask for height, they're talking about a vertical height. Just so you always know, we can assume it's vertical. And so your right angle is implied right there. Well, once you have the picture, the problem is easy, okay? If we look at our angle, let's look at what sides we have. We have the hypotenuse, and we also have the side marked H is the opposite side. And so we need to use our trig function that uses opposite and hypotenuse, and that is sine. And once again, when you've chosen your formula, just plug in what you know. I know the sine of 28 degrees will be my opposite side, which is H, over my hypotenuse, which is 72. And again, since it's divided by 72, we're just going to multiply both sides by 72. And when I do 72 times the sine of 28 degrees, I get approximately 33.8 feet. And that's the height of the parasailer above the water. Again, any questions you have, whether it's how I set up the picture or how I know which formula to use, please write those questions down here and we will address those first thing in class tomorrow.